All right, welcome to Physics Video 4.3. We're going to learn today about velocity vectors and components of velocity vectors. This should hopefully be a pretty short video. So here's your two objectives. You should, by the time you're done watching the video here, understand the idea that an object's motion, an object's velocity, can be in a direction which is horizontal, which is this way, vertical, which is this way, or a combination of both. Okay. Secondly, you should understand the concepts of horizontal velocity and vertical velocity. All right, so that is where we are headed. Before I get too far, I guess I should comment that if you don't know, horizontal is this way, vertical is this way. That's worth writing down if you did not know that. I used to always forget. And somebody once told me that the horizon runs horizontally. And that has helped me remember that ever since then. So there you go. Okay, so let me give you a couple definitions here. Horizontal velocity, we're going to use the symbol Vx to measure horizontal velocity, is simply a measure of how fast an object is moving to the left or the right, or maybe forwards or backwards, or east or west, or whatever. And it completely ignores any motion up or down, or north or south, or whatever. Okay, and vertical velocity, what we're going to call Vy, is the opposite. That's a measure of how fast the object is moving up or down, or north or south, and it completely ignores any motion left or right, forwards or backwards, or east or west. Okay, and hopefully you're picking up on the notation here. Check it out. In math class, when you graph stuff, you have two axes, right? There's the x-axis and the y-axis, right? And hopefully you're now realizing, oh, the x-axis runs horizontally. And so that's why we call the horizontal velocity Vx. All right. And the vertical velocity, Vy, runs up and down along the y-axis. So there's your vertical velocity. Okay. The same thing can happen for forces. You can have horizontal forces and vertical forces. So you have Fx and Fy. We, for the regular physics class, are just going to focus on velocity. Okay. So probably the easiest way to understand this is by doing a couple simple examples. The big thing to keep in your head is this idea here, that the x-axis runs horizontally, it runs left and right, and the vertical velocity runs vertically. The y-axis runs vertically, up and down. Okay, so let's do a couple of really simple examples, all right? So first of all, I would like you to imagine a very fast ant crawling north at 3 meters per second. Okay, so here's our ant. Why his face is on the top of his head, I don't know, deal with it. So there's your ant. All right, he's going to crawl north. So he's right here, and he's going to go like that, north at 3 meters per second. Okay, so here are three things that we could say about the ant. We could say that the ant's velocity is 3 meters per second. Okay. Notice I can't just say positive 3 meters a second because, well, I guess I could, but in a minute you're going to see that's going to become confusing. So instead of just saying positive 3 meters a second, I'm going to actually write the direction. And I'm going to say his velocity is 3 meters a second north. Okay. Because at this point, just saying positive could be confusing. It might mean north, it might mean east. In the case of this problem, it's north. All right, so now let's talk about horizontal velocity. Let's talk about horizontal velocity. Horizontal velocity is a measure of how fast he moves this way, right? And so it's kind of a dumb question. How fast is he moving left or right? How fast is he moving east or west? And the answer is he isn't. Look, he's just going north. He's not making any progress east or west. All right. So for our ant, the horizontal velocity is actually 0 because he's not moving horizontally. Not moving horizontally, right? Okay. And the vertical velocity is a measure of how fast he's moving in a vertical direction, which in this case is 3 meters a second. And here, just saying positive is enough because I know vertically I can only go up or down, and positive implies up. Okay? So these are three things that I know about my ant. I know his overall velocity is 3 meters a second north. I know horizontally he's not moving, and I know vertically he's moving north positively at 3 meters per second. Okay? So now let's imagine an ant sleeping on a conveyor belt. All right? And it says, suppose the belt carries the ant east at 4 meters per second. So what you've got here is you've got a conveyor belt. Zoop, zoop. Okay, and sitting on the conveyor belt is the ant. All right, so there's our ant who is sleeping on the conveyor belt. He doesn't look like he's sleeping. Deal with it. All right, so he's just hanging out. He's not moving, except that he's on this conveyor belt, and the conveyor belt is going this way. So, right, carrying him along that way. So even though he's not physically moving, the conveyor belt is causing him to move. All right. So once again, there are three things that we know about our ant. Okay. This time we know that his overall velocity, the velocity of the ant, is 4 meters per second. Again, I'm going to write the direction. Okay. Now let's talk about horizontal velocity. Horizontal velocity is a measure of how quickly the ant is moving in a horizontal direction, east or west. And, well, how fast is he moving? He's moving at 4 meters a second in a positive direction. Okay? And then finally, what about our vertical velocity? Vertical velocity is a measure of how fast he's moving in a vertical direction. How fast is he moving up or down, or in this case, north or south? And the answer is he isn't. The conveyor belt's just moving. The conveyor belt is just moving east. He's not moving north or south at all. So our Vy is 0 because he's not moving vertically. Okay? So our final question then, you can probably guess where we're going with this, is what if we do both? All right? So we've got a very fast ant crawling north at 3 meters a second, but he's on a conveyor belt that's carrying him east at 4 meters per second. So here's what we need to visualize. We need to have a conveyor belt. Top line of the conveyor belt. Here's the bottom edge of the conveyor belt. There's our ant. Okay. So what's going to happen here is this. As the ant moves, he's crawling this way at 3 meters per second, right? He's crawling vertically at 3 meters per second. All right, and because he's on this conveyor belt, he's also moving, whoa, that's not what I wanted to do. He's also moving this way horizontally at 4 meters per second, right? So think about what's going to happen. In 1 second, he's going to move north 3 meters, and he's going to move east 4 meters. So after 1 second, my ant is going to be right there, right? So look what has happened. In that amount of time, our ant has gone this way 4 meters, and he's gone this way 3 meters. So his overall velocity, his overall displacement, I should say, is he went 4 meters this way, 3 meters this way, which means he actually traveled this way, right? Okay. So at this point, we got to do a little bit of Pythagorean theorem and figure out how far he went, right? So what you learned in math class is this. A squared plus b squared equals c squared, where you're dealing with a right triangle with two legs of length a and b, and the hypotenuse is length c, right? So for us, we've got 4 meters squared plus 3 meters squared equals c squared, right? So you guys have hopefully seen this before, right? 16 square meters plus 9 square meters equals c squared. 25 square meters equals c squared. So we're going to get 5 meters, right? Take the square root for both sides. So what happened is, and this is the important part. So if I just lost you with the math, we'll talk about this more in class, but here's the important part. Check it out. In 1 second, what did our ant do? He went horizontally 4 meters. He went vertically 3 meters, but overall he traveled 5 meters in 1 second. that means the ant's velocity is 5 meters per second in a direction that technically we'd need to find an angle to measure. We're not going to worry about that in this class, but we can measure that angle. For us, we could just say, I don't know, what is that, northeast, right? Because he's going both north and east. All right? So look, here's the velocity of the ant. He's going at 5 meters a second to the northeast, not directly northeast, but he's going both north and east. And then he's got two components to his velocity. He's got a vertical component that tells you that he's going 3 meters a second to the north, and he's got a horizontal component that tells you he's going 4 meters a second to the east. Okay? So this problem was a little bit weird because, or maybe not weird, maybe oversimplified, because the two components are pretty obvious, right? Because the horizontal component is due to the conveyor belt moving, and the vertical component is due to the ant moving. So in the real world, that won't always happen. All right, so let's take a look at one last thing here. Let me see if I can get this to work. All right, so what we've got here is a ladybug. I seem to have a bug fascination here. And our ladybug is going to crawl across the screen. All right, so there he goes. He's just crawling. Don't squish him. He hasn't done anything to harm you. All right, so he's just going to crawl across the screen like that. All right, let me rewind it and play it again. Before I do, though, let's mark his starting spot. So start. Okay, and then let's hit play, and I'm going to just count seconds to sort of imagine time elapsing. So I'm going to go 1 Mississippi, 2 Mississippi to indicate seconds passing. So here we go. I'm going to hit play, and here we go. I said I'm going to hit play. Oh, I see. I'm going to hit play, and here we go. So ready, set. Oh, damn you. Okay, 1 Mississippi, 2 Mississippi, 3 Mississippi, 4 Mississippi, 5 Mississippi, 6 Mississippi, 7 Mississippi, 8 Mississippi, 9 Mississippi, 10 Mississippi. All right, so in 10 seconds, that's where our ant got to, or our ladybug got to, right? So here we know that our time is 10 seconds. Let me move that. We know that our time is 10 seconds. Okay, and what I could do is I could use a ruler and measure this distance, all right, and figure out how far my ant had traveled, right? Okay, so I'd have a displacement that way. I'd have, yeah, I'm getting ahead of myself. All right, so anyway, the point is, if I measured this distance here that I just drew with this black line and divided it by 10 seconds, I could find the velocity of the ant, right? So I'm going to, you can't see me do this, but I'm going to grab a ruler and measure this line, and it turns out to be, I'm going to lie, let's just say 100 centimeters. Okay, so what that means then is his velocity is going to be 100 centimeters in 10 seconds, or just 10 centimeters per second, right? Well, as he does that, he's moving this way, and he's moving this way, right? Okay, and so how quickly the ant was moving this way would be a measure of his horizontal velocity, and how fast he's moving up would be a measure of his vertical velocity. Okay, so here again you'd have to do a little bit of trig. We're not going to get into it. There's a way you could measure this angle and then use sine and cosine to figure out your Vx and your Vy. We are not going to do that. So I'm going to just tell you what these numbers are. Let's suppose we figured it out, and maybe this guy comes out to be, gosh, why am I suddenly drawing a blank on this? What would work? I think if I make this 80 centimeters, and if I make the, yeah, and if I make this 60 centimeters, I think that works. So then that makes our Vx 8 centimeters per second, and our Vy 6 centimeters per second. All right. So I don't know if that last example helped any. Anyway, there you go, horizontal and vertical velocity. Okay. No, stop, stop.